Hello everyone. In this session we are going to discuss about S block elements, that is all about the alkali and alkaline earth metals. Okay, so as per your JEE syllabus is concerned, we need to study the preparation, the properties coming to physical properties or the chemical properties, as well as the uses of oxides, hydroxides, carbonates, bicarbonates, chlorides and sulfates. So you need to study about oxides, hydroxides, carbonates, bicarbonates, chlorides and sulfates of sodium, magnesium, potassium and calcium. Okay, so let's start with oxides. So oxides of, say, sodium. Sodium has two oxides, namely Na2O, Na2O2. Sodium oxide, sodium peroxide. You also have sodium monoxide, sodium, right? We'll come to that again. Now see, sodium oxide, and here you have one extra oxygen, that is sodium peroxide. How do we prepare Na2O? Preparation. So coming to its preparation, it's prepared from sodium nitrate and sodium nitrite. Like on treating with sodium, say for example sodium nitrate, NaNO3, sodium nitrite, NaNO2. When these treated with sodium, right, you get sodium oxide along with the elimination of nitrogen. So if you balance the equation, as two nitrogens are eliminated, so let's put 2 here, and you have 10 sodiums and 6 here. Here also you have 2 sodium nitrate and 6 and 4. But the purest form of sodium oxide can be prepared with the help of sodium azide. What is azide? You have how many nitrogens in an azide? 3 nitrogens. Sodium azide, when treated with sodium nitrite, like this, here you get the proper plus N2. So here again you have 2, because as there is elimination of nitrogens, 5 here and again 2 here. So with the help of azide, that means azides when treated, that is sodium azide, when treated with sodium nitrate, the purest form of sodium oxide is obtained. Okay, let's look at the properties. Properties of is sodium oxide. Sodium oxide, they react with water. What happens when sodium oxides react with water? They form hydroxides. That means you can say this is one of the preparation of sodium hydroxide. They can also react with oxygen at 500 degrees centigrade. This forms Na2O2. One extra oxygen is included. Sodium peroxide. So I can say this 2 here, 2 here. So on treatment with water, it forms sodium hydroxide. With oxygen, it is forming sodium peroxide. Sodium oxide when treated with liquid ammonia. So I can say this as a liquid ammonia. What happens? NaNH2. Sodamide NaNH2 is with NaOH. So these are some of the properties of sodium oxides. What is the main use of it? Sodium oxide is mainly used as dehydrating agent. Dehydrating agent as well as polymerizing agent. Polymerizing agent. What is dehydrating agent? Agent that eliminates water from a molecule. Removal or elimination of water. Whereas polymerization, which includes the polymer formation, right? Which helps in forming a polymer chain, right? Let's look into the another compound, that is Na2O2, sodium peroxide. As we have seen already, how do you prepare sodium peroxide? Sodium oxide, when treated with oxygen, say around 500 degrees centigrade, there is formation of sodium peroxide, right? There is formation of sodium peroxide. So this is one preparation. So if you look at the properties of sodium peroxide, Na2O2. Na2O2, they reacts with water. In the same way how sodium oxide is reacting with water here also. But the number of moles of formation of sodium hydroxide is different from that of the sodium oxide. Here there is formation of around 4 moles of sodium hydroxide with the elimination of oxygen. So here also sodium oxide, that is peroxide, when treated with carbon dioxide, Na2O2 with carbon dioxide, it forms Na2CO3 plus oxygen. Reacts with moisture, reacts with carbon dioxide, even it can react with carbon monoxide also. Na2, that is sodium peroxide, when treated with carbon monoxide, it forms sodium carbonate, right? So you can see this one, benzoyl chloride. This is C6H5COCl. If you have C6H5Cl, that is benzyl chloride or chlorobenzene. This is benzoyl. I will write here benzoyl chloride. This, when treated with sodium peroxide, it forms a compound like this, where chlorines are eliminated. 2 molecules of this, a compound is formed in this way, where COO, again CO, a dimer. There is formation of a dimer. So we call this as a benzoyl peroxide. Formation of benzoyl peroxide with benzoyl chloride. Upon treatment with sodium peroxide, it forms benzoyl peroxide. Now Na2S plus oxygen, what it forms? Sodium sulfate. Just like Na2O2, when treated with oxygen, it is forming sodium sulfate. Here it forms sodium carbonate. So by looking at this especially, what can you see? That means, what is the main use of sodium peroxide? Sodium peroxide can be used for purification of air. It can be used purification, because you can see the above reactions, wherein which it is reacting carbon monoxide that is present in atmosphere, carbon dioxide again present in atmosphere, the water converting to sodium hydroxide and sodium bicarbonates. So it is mainly useful for the purification of air. It is also used as oxidizing agent. It is used as bleaching agent. So these are the main uses of sodium peroxide. So we have seen 2 oxides. One is sodium oxide, other is sodium peroxide. Now the next element in group 1 is potassium. Let's see K2O. potassium monoxide. It can be prepared like this. So preparation of this with the help of potassium nitrate and potassium, wherein which you get potassium oxide and elimination of nitrogen. So you have 2 here, 10 here and 6 here. This is the main preparation. If you look at the K2O2, what is this? K2O2, potassium peroxide, like this, K2O2. What happens when this is treated with water? What happens when sodium peroxide is treated with water? Formation of sodium hydroxide. Here there will be formation of potassium hydroxide with formation of hydrogen peroxide. So here you have 2 here. Okay, now look at this, potassium dioxide. When potassium dioxide is treated with water, same case as here, it forms potassium hydroxide plus formation of hydrogen peroxide plus elimination of oxygen, also liberates oxygen. Means potassium oxides or potassium dioxide, when treated with water, there is a liberation of water. So because I'm just emphasizing this because it has a main use. What is the main use? What is the main use of this? As it is liberating oxygen, means it is acting as a oxidizing agent. Means, for example, potassium oxide is used as an air purifier, wherein which we are using this in the space capsules, right? Even in the submarines, right? So as a breathing mask especially, right? Because this potassium oxide, upon exposure to atmospheric moisture, it is liberating oxygen. So we can use this as a breathing mask, as it is producing oxygen and it also removes the carbon dioxide. So this is the main purpose. So students, I just want to ask you a question here. Now, you all know that sodium and potassium are stored in kerosene, right? Now my question is, why lithium is not stored in kerosene? Not stored in kerosene. Why only sodium and potassium? Even lithium is reactive. Okay, but lithium we are just wrapping it. Like you know paraffin wax, right? We are wrapping in the paraffin wax. But whereas for sodium and potassium we are storing it in the kerosene. So the reason is lithium is light in weight. Light in its weight means if you add lithium to kerosene, it floats on kerosene, right? That's the reason why we are not storing lithium and kerosene, and we are storing only sodium and potassium in the kerosene, whereas lithium is wrapped in the paraffin wax. Okay, this is something which I want to ask you. Now I want to discuss about the oxides of calcium. So oxides of calcium, as you know, calcium oxide, that is quicklime. Okay, quicklime here also called as burnt lime. So how can we prepare calcium oxide? Just by heating calcium carbonate upon heating to 1000 degrees centigrade. You can see this is a reversible, wherein which formation of calcium oxide plus carbon dioxide, as there is a liberation of heat, 42 kilocalories. So this is how we are preparing the calcium oxide from calcium carbonate. The main properties of this calcium oxide, usually calcium oxide reacts with silica, the acidic impurities. Okay, calcium oxide reacts with an acidic impurity like silica or silicon dioxide, and it forms calcium silicates. One of the important property. So why is it so important? Because calcium oxide can be used as a basic flux in the metallurgy process. Basic flux. If you see in the metallurgy, the extraction of the metals, calcium oxide can be used as a basic flux. Also, calcium oxide can be used as a metal furnaces. I mean the outer coating metal of the furnaces. Also, it is used as basic flux so that it can remove. Silica is nothing but the sand, the clay. So it can remove the acidic impurities like silicon dioxide, because it can react with silicon dioxide and form calcium silicates. So calcium oxide can also be used as disinfectant and as germicide. Okay, you know what is germicide, right? Germicide is something like which kills the germs. That includes bacteria, virus, or the fungi. Whereas disinfectant, see disinfectant, how different it is from sterilization. Sterilization or the disinfectant is complete elimination of microorganisms. But there is a slight difference between these two terms. Sterilization is used when you are applying a, say, an ingredient or a medicine on animate objects, whereas for disinfectant it is on inanimate objects. Say for example, I can say Dettol. Dettol sterilizes, means it can be used on human beings or on living tissues. There we can use the word sterilization, whereas a disinfectant which we are using on inanimate objects or non-living organisms, like I can say Cresol. Okay, so that is a disinfectant. The same way calcium oxide can be used as a disinfectant, as well as germicide, as well as a basic flux, right? So we can also use as in the softening of water, calcium oxide. What happens when calcium oxide is reacting with water? It forms calcium hydroxide with energy. You know limestone, right? Limestone is nothing but calcium carbonate. When limestone is heated up to 1000 degrees centigrade, there is formation of calcium oxide, that is your quicklime. Quicklime, when treated with water, forms calcium hydroxide. Limestone, quicklime, this is slaked lime. Slaked lime can suspend this in water, and once you filter it out, you get a clear solution. The clear solution of calcium hydroxide, we call it as a lime water. Again, this is a calcium hydroxide, don't confuse. If you have the suspension, that is same suspension of calcium hydroxide, we call this as a milk of lime. Okay, so limestone is the calcium carbonate, where upon treating at 100 degrees centigrade it forms calcium oxide. When treated with water, it forms calcium hydroxide. When suspended in water and filter out, The clear solution of it is called as lime water, whereas the suspended solution of it is called as milk of lime. Let us take another compound, MgO, magnesium oxide, also called magnesia. Okay, how do you prepare magnesium oxide? Very simple. Magnesium, when treated with oxygen, upon burning, it forms magnesium oxide. See, calcium oxide, students, I have there was a doubt asked from you. Calcium oxide is not used as a metal furnace. I'm saying calcium oxide is used as a lining of the metal furnaces. Right, just make out the difference. It's used as a furnace linings. That's it. And one more thing, magnesium, this is upon burning, the same thing, but not only burning but upon heating also, magnesium oxide plus water. Whereas magnesium nitrate, when heated up, you get magnesium oxide plus nitric oxide and oxygen. So here you should have 2 here, right? So this is the how do you prepare magnesium oxide. Okay, let's look into the next one, the properties of these. Magnesium oxide, what happens when it is treated with water? Yes, magnesium hydroxide, this upon heating. Whereas magnesium oxide, when treated with hydrochloric acid, it forms magnesium chloride and water. So wherein which you have 2 here, right? So magnesium oxide, that means when treated with acids like sulfuric acid, magnesium sulfate, water. So these are some of the properties of magnesium oxide and how we can prepare magnesium oxide. Magnesium oxide we are preparing by burning of magnesium, by heating of magnesium oxide, and by heating magnesium nitrate. Okay, what is the main use of magnesium oxide? The best use is antacid. See, uses are something like where you can expect in the examination, especially in the mains. Okay, so because this one, the uses of here as well as you can correlate in the chemistry in everyday life, because antacids, these are something which you are learning, right? So magnesium oxide is used as antacids. Okay, that means to treat acidity, right? Against acid and anti-acids, right? They are against acid. That means in order to treat acidity, magnesium oxide can be used. Apart from that, it can be used as an insulator. Basically, when this is mixed with asbestos. When mixed with asbestos for steam pipes and boilers. And boilers, insulators. These are the main uses, but this is the ultimate use where especially the magnesium oxide still under use. So if you have you ever heard about the Gelucel, the advertisement, right? If you can see the ingredients of the composition, you can find the several alkaline or alkaline earth metals with magnesium hydroxide, magnesium oxide, because these are the main purpose of these oxides are used or serving as the purpose of the antacids. You can just have a look at that. If you have a bottle in your home, like just turn the bottle back, you can see the active ingredients. There you can observe, right? Okay, something about, we have seen all about the oxides. Let's look into hydroxides. The first hydroxide and the best hydroxide, sodium hydroxide. Sodium hydroxide, like, see, when sodium carbonate is treated with calcium hydroxide, what happens? Formation of calcium carbonate plus formation of NaOH. This happens as a precipitate. Sodium carbonate treated with calcium hydroxide forms calcium carbonate. Calcium carbonate happens, it forms as a precipitate, and there is formation of sodium hydroxide, the best method. Okay. The next one, the properties. If you look at the properties of these sodium hydroxide, they have several chemical properties, like sodium hydroxide when treated with sodium hydroxide when treated with ferric chloride forms ferric hydroxide and sodium chloride. So I'm just not balancing this. You can have a look at the ingredients what are formed. Sodium hydroxide with ferric chloride. Okay, what happens when it is treated with ammonium chloride? It forms again NaCl plus ammonia plus water. What is the smell of ammonia? Ammonia is pungent. See, ammonia usually it is a gas, but in laboratories, if you see, is in a liquid form. If you open the bottle of ammonia, it smells very bad that you cannot stay at the laboratory, because it's very pungent and it is very, immediately tears start flowing from your eyes and you cannot bear the smell. It's so pungent. So apart from that, there is formation of sodium chloride and water. Now Al2O3, aluminum oxide or alumina, when treated with sodium hydroxide, sodium aluminate, this one, sodium aluminate with the elimination of water. So this is some of the properties. Or you can see phosphorus. Yes, phosphorus when treated with sodium hydroxide with water, it forms phosphine, because this is one of the preparation which we can see in the phosphine formation, as well as sodium hydrogen phosphate, right? So these are some of the properties. Okay, can you tell me what is the uses of sodium hydroxide? Where you have seen the sodium hydroxide, where you have come across the sodium hydroxide? First thing, as a reagent in our laboratory, right? Then it can be used in petroleum refinery. Then where you have come across? Have you heard about the reaction saponification? What is saponification? Formation of soap. Sodium or potassium salts of soap, right? Sodium or potassium salts of saturated fatty acids. Means fatty acids when treated with sodium hydroxide or potassium hydroxide, it forms soap. So, right, formation of soap or soap making. Then it's also used in the manufacture of, like, paper, dyes and drugs. See, drugs includes like medicines, we can say. Okay, so generally all the medicines are either weak acids or weak bases. They are neither strong acids nor strong bases. All the medicines are weak acids or weak bases. So if you have a medicine wherein which you need to reduce its acidity or basicity, or especially the acidity, you are making a salt of it with fusing or reacting with sodium, so that the acidity of the so and so drug can be reduced. Okay, let's discuss about potassium hydroxide. What is another name of potassium hydroxide? Caustic potash. So we prepare like this: potassium hydroxide. Potassium sulfate, when treated with barium hydroxide, there is formation of barium sulfate with liberation of potassium hydroxide. Okay, so the main properties of potassium hydroxide includes absorption of carbon dioxide. So potassium hydroxide, mainly the main property of it, like physical property, it absorbs the carbon dioxide. So it is caustic potash because potassium bicarbonate formed will be, like after sufficient absorption of this, the potassium hydroxide. So you can say it forms, sorry, you can just ignore this, right? You can say alkaline reagent. Alkaline reagent. We can say the potassium hydroxide is also an alkaline reagent. Like we can say potassium hydroxide is not used while sodium hydroxide is used, because sodium hydroxide is cheaper than potassium hydroxide. So we can say potassium hydroxide is also an alkaline reagent, especially used in the laboratory, but we prefer sodium hydroxide over potassium hydroxide because sodium hydroxide is economical. That means it's cheaper. What is calcium hydroxide? We just have seen calcium hydroxide is also called as slaked lime. Very simple preparation: calcium oxide, where you have quicklime, when treated with water forms this calcium hydroxide. When treated with carbon dioxide, calcium bicarbonate plus water. So this is main preparation. If you look at the magnesium hydroxide, this is magnesium hydroxide. Magnesium hydroxide, like magnesium sulfate, when treated with sodium hydroxide, there is formation of sodium sulfate plus magnesium hydroxide. So this is the main preparation of this magnesium hydroxide. Apart from this, see, the main properties of magnesium hydroxide includes, like you can convert oxides on heating. That means magnesium hydroxide can be converted to magnesium oxide like this. If you heat magnesium hydroxide, it's converted to magnesium oxide along with the elimination of water. Magnesium hydroxide, it is when treated with ammonium chloride, it forms magnesium chloride plus ammonium hydroxide. Okay, so as I mentioned before, what is the main use of magnesium hydroxide? The main use of magnesium hydroxide, as mentioned earlier, with magnesium oxide, it is used as an antacid. You can under the trade name, you can see it's called as milk of magnesia. Magnesium hydroxide, milk of magnesia. Okay, I have a simple question for you. I'll give you, like, say sodium hydroxide. We have seen what is a calcium hydroxide. Then potassium hydroxide, let's say beryllium hydroxide. Now, among these, which is a weak base or weakest base? Weakest base among these. What is the weakest base among these? And what is the reason? What is this? Beryllium hydroxide is the weakest base. This is weakest because alkali metal hydroxides are more stronger bases. Alkali metal hydroxides are more stronger bases than alkaline earth metal hydroxides. So you can see these belong to alkali metals. This is an alkali earth metal. So if you can remember this, alkali metal hydroxides are stronger bases. If alkali metal hydroxides are the stronger bases, then this is an alkaline earth metal, this is a weakest base. So the basic character of hydroxides of alkaline earth metals increases down the group. That's the reason why beryllium hydroxide is the weakest one. Right. So this is, so far we have seen all about the oxides and hydroxides of the group 1 and group 2 metals. So in group 1, where we have seen sodium oxide, potassium oxide, sodium peroxide, potassium dioxide. Right, in group 2 we have seen the calcium oxide, then magnesium oxide. Whereas in the hydroxide part, we have seen sodium hydroxide, potassium hydroxide, calcium oxide, calcium hydroxide, and magnesium hydroxides. So basically, from JEE Main's point of view, for the exam point of view, in S block elements especially, you need to focus more on the, say, synonyms, uses, the basicity part. Whereas the periodic trends, if you consider, this you have to cover in the previous, like, you know, the chapter periodicity, the trends regarding their atomic size, atomic basicity, say electronegativity, ionization enthalpy, electron gain enthalpy. So all these things you need to cover, okay, in periodic table, including the exceptions. Okay, so focus more on the diagonal relationship here, okay, with a few exceptions wherever they are present. Apart from that, if you look at the preparation, properties, and the uses, focus more on the uses as well as synonyms, and slightly about the preparations, especially, like, you know, where exactly the exceptions are there. Okay guys, so this is all about the S block elements. Okay, thank you.